Hi class, we're now on chapter 7.5. We're going to be dealing with aqueous solutions and solubility. So an aqueous solution is a homogeneous mixture of a substance with water. A perfect example of this would be vinegar. Vinegar is acetic acid in water solution. So it's one layer. That's what I mean by one layer. You cannot tell that there's two different compounds in there because there's only one layer. When ionic compounds dissolve in water, they usually dissociate into their ions. So if you add sodium chloride, if you look at this picture, it doesn't stay intact as a salt crystal. It dissolves and stays in the solution as ions. The sodium ions float all around and the chloride ions float around, but they do not come back together. They stay as ions. So a compound is soluble in a particular liquid if it dissolves in that liquid. So salt is a perfect example. We can add salt crystals and you don't see salt crystals, you see just water because they dissolve. A compound is insoluble if it does not dissolve in the liquid. So I can't think of anything right now, but let's say that we added something, I think cinnamon. Cinnamon does not dissolve in water. You can stir it and stir it and stir it, but it will not dissolve. It doesn't change at all. That's an insoluble compound. So substances such as sodium chloride completely dissociate into ions, and they are called strong electrolytes, and we'll figure out why next. So a strong electrolyte is a solution that can carry a current. And it can carry a current so much that if you add a light bulb with some electrodes to it, and you stick this in the water, that light bulb, once this is plugged into a light source, the light will go on. It will be bright, depending on if you're dealing with a strong electrolyte or something that's not a strong electrolyte. We actually have this in class, but since we're online, you don't get to see this. We do have a little light bulb that has these electrodes. You just stick it into the solution, and you can tell based on the light bulb whether this is you're dealing with a strong electrolyte or not. So this is why you don't want electricity or radio and so forth stuff. You know, you see in movies, people get electrocuted. They get electrocuted because of the ions that are in the water, the calcium, these things that can carry a charge and will be attracted to the opposite charge electrode, which is what you see here. The sodium's attracted to the negative. The calcium chloride is attracted to the positive. However, pure water, which is in a physical state of an L, does not conduct electricity. It does not conduct electricity because it's all nonmetals, it's molecular. It does not have ions to it, it's H2O. Pure water, no impurities, does not conduct electricity. However, the water that we deal with out of the sink and so forth has minerals, has all of this to it. So it can carry a charge. So if you look here, here's a picture of the pure water. Nothing happens. The light bulb does not go on. However, if you stick this back into sodium chloride, you will see it very brightly lit, and that's because of the ions. Silver nitrate. Here's an example of silver nitrate. This is a polyatomic ion. This will also dissolve in solution. However, the polyatomic ion stays complete and intact. So when this separates, it separates into silver ions and nitrate ions. They do not come back together. They stay like this in the solution. But this is to point out that the polyatomic ions will stay intact. They will not separate into nitrogens and oxygens. This is also a strong electrolyte, which means that the light bulb will go on. It will be attracted to the electrodes. It can carry a current. Silver chloride. Silver chloride does not dissolve in water. It is considered a precipitate, which is a solid. So if you add these compounds, all you're going to see is this white powder precipitate at the bottom. It's just going to sit there. It is not going to be in ions. It's going to stay intact, and that is it. Doesn't want anything to do with the water. So it does not dissolve, remains as a solid. It will stay as S as a physical state of solid in the water, and it does not dissolve into its ions, so it's therefore considered insoluble. So here is a chart to help you understand. As we start doing more balanced equations, you're going to need to understand what happens with some of these compounds. So you're going to have to refer to the chart, which I will come up to on a couple slides. You definitely should know that chart. You should definitely have a copy of it. You should definitely write notes to it, whatever helps you on this. So a compound is soluble if it dissolves in that liquid. Compounds that are soluble. There's two charts. Make sure you're looking at the correct one. This is soluble, means it can go into the liquid. So if you have a compound that has any of these as part of that compound, nitrate, acetate, any of these, that's soluble. Doesn't matter what the other partner is. If it's attached to these, it's soluble. Compounds containing some of the halogens. Now, there are exceptions to the rules. So if you have any of these and they're attached to any of these, let's see. So I have some of these compounds. Does the compound partnered with any of these? If you say no, then it's soluble. So anything that's attached to the front of these that is not this is soluble. It will go into ions in solution. However, if I have any of these and they are partnered with any of these, it is insoluble. You will only have a solid precipitate, which is silver chloride. Here's a perfect example. If this is attached to this, it's not going to dissolve into ions. It's going to stay intact. And compounds containing sulfate. Does the compound contain any of these? If it's partnered with any of these, it is insoluble. It's going to stay intact. If it's not partnered with any of these, it will be soluble and it will be ions in solution. So the solubility rules indicate the compounds containing lithium ion are soluble. So for instance, I'm just picking lithium. You can have any other anion attached to it and it doesn't matter because it is soluble. There are no exceptions to lithium. The solubility rules state that the compounds containing nitrate are also soluble. So silver nitrate, lead 2 nitrate, calcium nitrate, they are all dissolved in water. They go into ions. They are also strong electrolyte solutions. All right, now this is insolubles. They do not dissolve. So compounds containing hydroxides. Now, if it's partnered with any of these, let's say yes, they are soluble. If it is partnered with none of these here, we go to this next one. Is it partnered with any of these? And if we say yes, it is mildly soluble, which means some of this will be in ionic form in the solution, but most of it will stay intact. Now, if it is not partnered with any of these, it is insoluble. It's going to stay as a solid. Compounds that contain sulfide. So sulfide here, if it's attached to any of these, it's soluble. If it is attached to none of these, it is not soluble. It's a precipitate. Same thing, compounds containing carbonate or phosphate. Any of these, it's soluble. And none of these, it's a solid. Okay, solubility rules state that with some exceptions, and there are exceptions, containing the carbonate ion are insoluble. So compounds such as calcium carbonate, iron 2 carbonate, strontium carbonate, copper 2 carbonate do not dissolve in water. So note the solubility rules do have exceptions. I'm going to go over the one in your book. For example, compounds containing carbonate are soluble when they have any of those lithium, sodium, potassium, or ammonium attached to it. So there are exceptions, and you have to make sure to understand how to read a chart. This is the chart you have. I'm going to show you how to read it. Now, if you have a compound, all you need to do is know what one of those atoms does. You don't need to confirm even the other one. But in most cases, you might not even have the other one on this chart. But one of either the cation or the anion should be listed on here, and that's how you can read it. So let's pick sodium chloride. I have sodium chloride. I want to know if it dissolves in water. I don't know. I'm going to look here. Compounds containing following ions are mostly soluble. If you see down here, this is mostly insoluble. So let's look at the soluble. This says lithium, sodium, potassium, and ammonium are soluble. There are no exceptions. No matter what they're attached to, they are soluble. They're going to be in ionic form in water. Same thing here, acetate and nitrate. Now we have chloride, bromide, and iodide. There are exceptions. So if I have any of these and they are paired with silver, mercury, or lead, they are insoluble. Anything else that's not listed, if it's not specifically listed here, it's considered soluble. Sulfate, if it's paired with calcium, strontium, barium, or lead, is insoluble. If it's paired with anything else, it is considered soluble. So let's say you didn't have something on here, chromate. Chromate's not on here. Dichromate, which is C2O7 with a 2- charge if I'm right. I don't see it on here, so I don't know how to read that. You don't need to. If you know what the cation that it's attached to, If that's on here, and it should be, you should never be given something that neither is on here. You might be given one that's not on here, for instance, dichromate. But if it's attached to sodium, you know what sodium is, it's soluble. So you may not have both the cation and anion listed on here. You don't need to. Don't panic. Look at the one that is listed. That's going to tell you what the behavior. If it's not listed as an exception on this top portion, it is soluble. Now this bottom portion is insoluble. Hydroxide and sulfide are insoluble, except for when paired with, ta-da, the ones that are listed up here. Carbonate and phosphate. They are insoluble. They still will stay as a solid. That's what this means, except for when paired with, ta-da, the ones up here. So that will help you understand. Make sure you get comfortable with reading this. We're going to do a couple problems to help you. All right. So is this compound soluble or insoluble? It is silver and it is bromide. Silver's not listed there. This is a perfect example. I don't see silver listed here. I don't see silver listed here. I'm going to look at bromide. So let's go to bromide. Bromide is right here. So it is under the soluble. However, there are exceptions to this. So let's see if silver is an exception, which means it is soluble unless it is listed here, then it is not soluble. It is a solid. So here we have silver, mercury, and lead. The compound is insoluble. I have silver. This is an insoluble compound. Calcium chloride. So here we are again. I don't see calcium, but I see chloride. There are exceptions to the rules of silver, mercury, and lead. This is calcium. It is not one of these, so it is soluble. Lead to nitrate. So let's look. I don't see lead here. I don't see lead here, but I see nitrate. Nitrate has no exceptions. This is soluble. And I have lead to sulfate. These are paired together. That's why I'm not changing the slide. Sulfate is not. Oh, there it is right here. I jumped the gun. Here is sulfate. So let's see if there's any exceptions to sulfate. We have paired with calcium, strontium, barium, or lead. So this is insoluble. So this one is soluble. This one is not soluble. And that is how you, hopefully this makes sense on how to read this chart.